All right, guys, welcome to another lecture here. Today we're going to be talking about the nasal bones and the zygomatic arches of the facial bones. I know you probably may have not covered them yet, but they're very simple anatomy, very simple anatomy of the cranium. That shouldn't be a problem looking at them and understanding them and knowing where they are, so they wouldn't be hard identifying them on radiographs. So again, we are going to go over the nasal bone zygomatic arches for this week. Let me bring up the PowerPoint. All right. So just as a reminder, your skull positioning lines, make sure you look over those, you memorize those, you know where they are. That way you can know, understand where they are and how to position them for certain projections. Make sure they're parallel, perpendicular. So make sure you look over those. So here's a routine for the nasal bone. You got a lateral, and that's the only one you're going to see for nasal bone in the book on page 423 is a lateral because they use the other projections from the facial bone series. So the parietal canthal waters is from the facial bone series. It's on page 420. And we are going to be using that projection quite a bit for a lot of the exams that we have going forward. They're going to refer back to that parietal canthal waters of the facial bones on page 420 because it just shows a lot of the facial bones in general. The expansion projection is a P-axial Caldwell. Again, you see it's a facial bone projection on page 421. So we will refer back to the facial bone projection for that. All right, so first thing we're going to do is kind of go over where the nasal bones are. So the nasal bones are two very small, delicate bones that are located right here in front, right? These two bones right here, get your little side view. Those right there are your nasal bones, right? So if you feel it on yourself, it's right up here, the very hard part. The part down here, right, is all cartilage. If you notice, the nasal bone isn't very long, right? It's very small, on the very top portion, and the rest of it is just cartilage, okay? So a lot of this, again, fragile bone gets fractured quite easily when there's trauma to the nose, so. That's what we're going to be going over for these first projections. All right. First one is the lateral nasal bone. So this one here is performed just to make sure there's no pathology or fractures of the nasal bone. Normally, you'll do both sides for comparison, right and left. Sometimes they'll just do just the affected side, but it just depends on department protocol. But where I work, they did both sides. KVP, if you notice, is a little lower, 65 to 75. Now, remember, the nasal bone is a small bone, very delicate, does not a lot to go through, so the KVP is a little lower. 40-inch SID, erect or prone position as needed for patient comfort. So if they're more comfortable doing it standing up or laying down, your choice. There's not one that's preferred over the other. Get the head in a true lateral position. So remember, there's 4 things to make sure that you get the head in a true lateral position. So those 4 criteria are making sure that the IPL, right, is perpendicular to the image receptor. The IPL is that line that goes through the pupils, right, interpupillary line. Make sure that is perpendicular to the image receptor in front, all right? We also want to make sure the mid-sagittal plane, which is the plane that comes down this portion of the body, is parallel to the front edge of the image receptor, all right? Then you also want to have the IOML, right, which is that line there, perpendicular to the front edge of the image receptor. Okay, so my image receptor front edge was here, right? You want this IOML to be perpendicular to it. Then you want the GAL to be parallel, right, to the front edge of the image receptor. Okay, so again, 4 things, and it's kind of hard for me to show you on the skull and for you to see it, but just know that 4 things are interpupillary line, which is the IPL, perpendicular to the image receptor. The MSP, mid-sagittal plane, parallel to the image receptor. The IOML, the interorbital meatal line, is perpendicular to the front edge of the image receptor, and the GAL is parallel to the front edge of the image receptor. Okay. All right, once you've done all that, you get them in a true lateral position. Now we need to find our centering spot. Centering spot is going to be a 1/2 inch inferior to the nasal bone, right? 1/2 inch inferior to the nasal bone. So to find that, let's go here. All right, what we're going to do is we're going to bring this guy up a little bit, get him in a lateral position there. So what we're going to do is we're going to find the nasion, which is right here. Right, here's the nasion. And we're going to go 1/2 inch inferior to the nasal. So that's kind of where we want to center, right? Kind of in the middle of the nasal bone. So find the nasion on the side, go 1/2 inch below, and that's where you want to center. Right? Once you've done that, collimate, and you only need to collimate to a little like 2 inch by 2 inch square. You don't need to get a, half the skull on there. You want a very small collimation field. So let me show you this. So what you want is you want a collimation field about like that, okay? Very small. You don't need all the skull over here, right? You just need that very small collimation field. All right. Once you've done that, suspend respiration and make the exposure. All right. And again, do both sides if department protocol calls for it. Here's what the nasal bone looks like. Okay. And they've done both sides. All right. If you notice there, all right, very delicate small bone there and there. Okay. And then what we're looking for is any fracture along that nasal bone. Okay. You want to make sure there's no rotation. Very difficult to tell rotation, but you can kind of tell rotation right there, right? So you see this one line down there and this one line up there, right? That's kind of a little bit of rotation on that one. Okay. You want to see it more like this one where it's one line. Okay. Make sure you have close collimation, sharp lines, bony trabecular markings. Make sure there's no motion. Okay. But that's really what you want to see for nasal bones. All right. All this back here is going to be underexposed, which is fine because if you were to expose this normally in the back, the nasal bone itself would be overexposed. So, all right. That one's nothing too difficult on that one. The next one is the parieto-canthal waters projection, which is again on page 420 of the facial bones. So for this one here, it is kind of like a projection that's going to show everything of the facial bones. So you're going to see it used a lot for different projections. For this one here, we're looking particularly for the bony nasal septum. And the bony nasal septum is, let me show you the other. All right, is this guy right there? It's part of the ethmoid bone. That portion up there, right, is the bony nasal septum. It's part of the ethmoid bone, and then it's also part of the vomer. All right, but that is what we're looking at here. We're looking for this line. Let me see if I can draw it. This line there. All right, that line there is what we're looking at. All right, that's the bony nasal septum. So we want to do this projection to make sure that there is no deviation of that bony nasal septum, which means we don't want it going to one side or the other. Sometimes when there's trauma, you'll have one deviated to one side or the other, and that's going to cause some breathing problems. Okay, KVP 75 to 85. All right, 40-inch SID. The erect position is the preferred position for the waters, but you can do it prone. All right, it just makes it easier to do it erect. Okay, so for this projection here, what you're going to want to do is you're going to want to extend the head, right, and place the chin on the image receptor. Okay, so again, you're going to, and I know that people wanted me to show it bigger here. I'm going to raise the chin, put that chin on the image receptor. So you want it resting on the image receptor. Okay, it's going to look like the patient is trying to keep their head above water, right? They're trying to keep their head above water. That's what you want to do. You want to get it to where the MML, okay, which is from here to the chin. So I can do it this here. That line there, right, needs to be perpendicular to the image receptor. So my image receptor is the side edge over here of the screen, right? I'm going to get that MML and try to get it perpendicular to the image receptor. So I'm going to raise the chin to bring that MML perpendicular to the image receptor and place the chin on the image receptor. All right. Hopefully that's, y'all can see what I'm doing there. All right. Now, when you do that, what's going to happen is you're going to form a 37-degree angle between the OML and the table. Okay, so what that means is if I was to draw a line from here, whoops, sorry, let me go back. All right, so if I was to draw a line from here through the OML till it got to the table, right? And here's the edge of the table there. That angle there would be 37 degrees. All right. Now, the reason that's important is because that if you have a 37-degree angle between the OML and the table, that'll guarantee that you get the petrous ridges below the maxillary sinuses. Okay, and that's very important for this projection. In order for it to be a good waters projection, you need the petrous ridges below the maxillary sinuses. And I'll show you what it looks like on the image receptor, right? But if you look at the very bottom picture here, right, you'll see that, I'm just going to point to them. There are your maxillary sinuses, that kind of black oval there, that's maxillary sinuses, right? And the petrous ridges are going to be somewhere around here, okay? And you want them to be below those maxillary sinuses, right? And that's what that 37-degree angle between the OML and the table will give you. It'll make sure that the petrous ridges go below the maxillary sinuses. Okay. Once you've done all that, you're correctly positioned, chin on the image receptor, MML perpendicular, right? So chin on the image receptor, MML perpendicular, right? 37-degree angle between the OML and the table, right? We're going to center the CR to exit at the acanthion. Remember, the acanthion is right here in front, right? Right below the nose. You're going to center to exit at the acanthion, right? So if I was to draw this down, right, this should be exiting at the acanthion, right? They're a little off, but it should be exiting at the acanthion, okay? It's a parietal acanthial projection. So again, it tells you which way the beam is traveling. It's entering the parietal bone, which is in the back, right? And exiting the acanthion, which is down there, okay? Once you've done that, suspend respiration and make the exposure. Here's what it looks like. Now for this one here, the petrous ridges are going to be, you want them to be below the maxillary sinuses. So if you look down here, right, there are your petrous ridges, okay? That block of bone right there, right, is going to be what you want to see below the maxillary sinuses, which are right here. Okay, so if you see the maxillary sinuses there, you want these petrous ridges to be below those maxillary sinuses. If you have that, that means that the angle between the CR and the OML, I'm sorry, between the table and the OML was 37 degrees. You had the chin correctly extended. You had the MML perpendicular to the image receptor, okay? Now for this nasal bone projection, what we're looking at is we're looking at the bony nasal septum, which is that structure right there, that white line that goes down. So if you see it, it goes down this way, right? And I'll erase it so you can see it. But that's what we're looking at, that structure there. Okay, we want to make sure there's no deviation. It's not going this way or that way. It looks like it's pretty straight down the middle, right? But that's basically what we want to see on this nasal bone projection. Now, you don't necessarily need all of the facial bones on there, but most of the time when you do a Waters projection, you get everything on there. Okay, for rotation, what we're going to look at is the distance from the lateral orbital margin, which is right here, to the lateral cranial edge, which is the side of the head. If the distance is the same on both sides, then there's no rotation. Okay, and then just look for structures that are symmetrical. Okay, so if you look at the orbits, they're pretty symmetrical, they look the same. But ideally, you want to look at that distance from the lateral orbital margin to the lateral cranial cortex. Okay. And again, make sure you have sharp lines, bony trabecular markings. Okay, so again, for review, what you want to do for this Waters projection, raise the chin, right? Put it on the image receptor. Try to get that MML, which is the mentomeatal line from the chin to the EAM, get that line perpendicular to the image receptor. That'll help you form a 37-degree angle between between the IR and the OML. Okay, if you have that 37-degree angle between the OML and the IR, then you have the petrous ridges below the maxillary sinuses. Okay, the higher that angle is, the higher those ridges are going to go up towards the maxillary sinuses. Okay, so you want to have a 37-degree angle between the OML and the IR, which will give you those ridges below the maxillary sinuses. Okay, if you see those maxillary sinuses being projected in here, right, that means that you didn't extend the chin enough, right? You had the chin lowered, and that caused those sinuses to get in there, all right? Also, those ridges to get in those sinuses. So again, if you see the ridges within the sinuses, that means that you did not extend the head enough to get the MML perpendicular. All right. All right. Let's see if we can. All right, kind of hard. You can't really see the sinuses here, but yeah, it's not going to work. All right, so just know that, again, if you don't have the chin raised enough, you're going to get the ridges within the maxillary sinuses, and you don't want that. All right. All right, just kind of a review over some of the structures that we're going to see on these Waters projections. All right, so if you look at A, right, on the left-hand side of the actual, not the radiograph, but the skeleton, right? A is just the what's called the zygomatic prominence, right? And that's just kind of the bump on the cheek there that you feel, right? So A over here on the radiograph will correspond to the zygomatic prominence. V is just the body of the maxilla, okay? And your maxillary sinuses are actually below inside those maxilla. Okay, so you got one on each side. All right, then you have C, which is what we talked about, which is the perpendicular plate, right? And if you look at C on with the radiograph, C is what it's corresponding to there. That's the perpendicular plate. Okay, and that's what we want to see it deviated left or right. D is the anterior nasal spine, which is very difficult to see. It's right there, but it's that bony projection that you see on the front of the skull here, right? That is the anterior nasal spine. All right, right there, anterior nasal spine. And you'll probably go over more of this in your anatomy portion, but just give you a little overview of what it is. E is the zygomatic arch. Okay, we all will do a projection for those zygomatic arches. If you look at F on there, that is the coronoid process of the mandible. All right. Then if you look at G, that is the condyle of the mandible. Then you look at H, you got the mastoids of the mandible. I'm sorry, not the mandible, mastoid process of the skull. Then you have I, which is the angle, and then you have J, which is the foramen magnum. All right. All right, the last projection for nasal bones is a PA-axial Caldwell. So again, the positioning for the Caldwell is going to be the same as the one for the skull. We want to try to get the patient's nose and forehead on the image receptor, just like you see on the patient there. Nose and forehead on the image receptor. Try to get the OML perpendicular to the image receptor. All right. Make sure there's no rotation, no tilt. All right, and you're going to angle 15 degrees from the OML, right? 15 degrees caudate from the OML. So if this OML was extended out this way, you would go 15 degrees that way from the OML, right? Collimate, suspend respiration. Now, this is, again, another projection that's going to show the bony nasal septum, okay, of the nasal bones. And then, again, of course, it's also going to show other structures on the facial bones, right? But this is just for nasal bones itself. All right, so again, Caldwell, 15-degree caudal angle from the OML. And what you want to do on the patient position is make sure the nose and forehead, those two structures, are on the table to kind of get that OML perpendicular. All right, here it is. So again, criteria for a good Caldwell projection is you want to see those petrous ridges in the lower 1/3, which you do here, right? There's a ridge, right? And they're in the lower 1/3 of the orbit. All right. If they are up too high, that means that there was not enough angle. If they're too low, there was too much angle. All right. So here is the perpendicular plate that we're looking at. Right. Kind of a little, looks like it's a little bit deviated to one side, which it very well could be. But that's what you want to see right there. Then you have your anterior nasal spine there. Okay, and this is basically where it's another projection to show us the bony nasal septum in case you can't see it too well on the waters. It's usually not part of the nasal bone series in particular in most places, but they can do it just to kind of get another projection of the bony nasal septum. Make sure there's no rotation, and then check your optimal exposure factors. Make sure you have sharp lines, bony trabecular markings. For rotation, it's the same thing. Make sure you look at the lateral orbital margin, the lateral cranial cortex. Problem with this radiograph is you really can't see the side of the head, so you can't tell rotation. So if you get a radiograph like that where you really can't see the side of the head, then use structures that you know that are going to be symmetrical, like the orbits, right? Those should look the same. One shouldn't be bigger than the other or more elongated than the other, right? The petrous portion should look about the same, all right, on each side. Okay. All right, so again, for this one, PA-axial Caldwell, make sure you have your nose and forehead on the image receptor. What positioning line needs to be perpendicular to the image receptor? Should be the OML. Once you have the OML perpendicular, how much do we angle? Should be 15 degrees and caudal, right? 15 degrees caudal from the OML. Okay, so make sure you find that OML, make sure it's perpendicular, then angle 15 degrees caudal. All right. So that covered the nasal bone projections. Only 3 of them. Now we're going to go into the zygomatic arches. A couple of these projections can be a little bit tricky, but if you look at our routine here, SMV, we talk about an SMV with the skull. So we've gone over this already. A town, even though it says modified town, we've done a town projection before. So it's going to be a modified version of that, but the concepts are still fairly the same on a town projection. Then we have on the bottom here where it's a special, a parieto-canthal waters, which we just covered, right? Page 420. So again, another projection, another series that uses the same projection over and over. The really new one we're going to learn today is the oblique infrasuperior tangential projection. Now it can be a little tricky to understand, but that's the only new one that we're really going to look at, right? All right, so the zygomatic arch is made up of two processes. It's the process from the temporal bone and then a process from the zygoma. Okay, so if we look here, all right, the zygomatic arch is formed here, right? That's where the arch is. So that arch is formed by the zygomatic process of the temporal bone, right, which is this portion here. And then you have the temporal process of the zygomatic bone, which is right there. And then those two combine and they form the arch. Okay. So again, on the temporal bone, which is that purple one, that right there is the zygomatic process of the temporal bone. And then here's your zygomatic bone, right? And this right there is the temporal process of the zygomatic bone. Right, so they just kind of flip-flop names. But those two together form the zygomatic arch, okay? And that's what we're looking at. So this can get trauma. If you get, punched in, this thing will go in. So we want to make sure that we're able to see that small, delicate structure right there. First one is the SMV. So with the SMV, you want to make sure that you have 75 to 85 kVp, 40-inch SID. The erect position is the easier position because remember, you can put them in a chair and just have their head leaned all the way back. Try to get the vertex of the skull, right? The vertex of the skull, top of the head, on the image receptor. Okay, want to really extend extend the neck to bring the chin up. That way you can have the IOML parallel to the image receptor. Okay, so if you look here on this picture, there is the IOML and it is parallel to the image receptor. That's what you want to see. Okay, rest that vertex of the head on the image receptor. So you see the top of the head is resting on the image receptor. Now remember, the patient cannot hold this position forever, so you have to be very quick. So I would have everything else set up before you position the patient. Make sure there's no tilt or rotation, right? And you're going to CR perpendicular to the perpendicular to the IOML. So if you look at this CR, it is perpendicular to the IOML. Now it is also perpendicular to the image receptor, but that's just because the IOML is parallel to the image receptor. So ideally, yes, your CR should be perpendicular to the IR if the IOML is parallel to it. But if it is not, right, if it's angled, then you're going to have to adjust your CR to become perpendicular with the IOML. So what that means, if my patient cannot rest his vertex on the image receptor, right, and he's kind of like this, right, my IOML now has come this way. So what I'm going to have to do with my CR is I'm going to have to angle it to become perpendicular to the IOML. Okay, I'm no longer perpendicular to the image receptor. I'm perpendicular to the IOML. All right, once you've done that, you're perpendicular to the IOML. Now what you're going to do is you're going to center 1.5 inches below the mandibular symphysis or midway between the zygomatic arches. All right, so let's go to this over here. Whoops. Oh my God, why did I do that? There we go. Right, so now if I'm here like this, all right, what I'm going to do now is I'm going to center 1.5 inches below the mandibular symphysis, so about right there, right? Or it's midway between the zygomatic arches. Okay, so that's kind of where you want to center. All right, right at that spot. And you want to, these are the structures you want to see, the zygomatic arches. Okay, so you see that SMV projection allows you to see those zygomatic arches. Okay, so again, SMV, that's what we want to see. Once you've done that, you're centered at the correct spot. collimate and suspend respiration, okay? And this is what it should look like. You can see here, zygomatic arches on each side. You'll notice that all this in here is less exposure, but that's okay because we want to be able to see those zygomatic arches and they're very thin. If you were to make enough exposure in this area, that means the zygomatic arches would be overexposed. So you're going to see it kind of light like that. Okay, you want to make sure the zygomatic arches are in profile. Make sure they're symmetrical. That'll help you know that you have no rotation. So if they look symmetrical, no rotation, you're good. Optimal exposure factors, sharp lines, bony trabecular markings. Okay. So that projection is on page 425. All right. So again, also when you're doing the SMV projection, you want to make sure that the teeth are superimposed over the frontal bone. All right. So if you look here, right. Let's see. All right. Here's your frontal bone, right? And then there's your teeth, right? You want those two structures to be superimposed on each other. So if I was to rotate, you want those to be superimposed on each other, right? That'll help make sure you have a good SMV. If you see the forehead too much like that, or the frontal bone, that means that you're not extended enough. If you see your condyles, which is this structure there, right? So you see the structure, and I'll kind of zoom it and see if I can zoom it in. That looks much better. All right. So you see this condyle here, that structure there on each side. Those condyles should be free of these mastoid processes down there. Okay. If you see those condyles getting into those mastoid processes, then that means that you are not extended enough. Okay. That's one way. Other reason could be is that your CR is not perpendicular to the IOML. Okay. So again, either you're not extended enough or, right, so either you're not extended enough to do an SMV or, whoops. Again, either you're not extended enough to do the SMV, and this guy having technical difficulties here. Give me 1 second. All right. Either you're not extended enough, okay, so you were kind of like this, or your CR was not perpendicular to the IOML. And that's it. Your zygomatic arches. Again, make sure they're seen in profile. And if you're not, then you have some rotation problems. All right. The next projection is on page 426. And it is the oblique infrasuperior tangential projection, right? So this one here is taken in case there has been some type of compression or depression fracture where that zygomatic arch has been pushed in and it's very hard to see on a normal SMV. We'll do this oblique projection to see that particular zygomatic arch. For this one here, both sides are generally taken for comparison, 75 to 85 kVp, 40-inch SID. Put the patient in the erect or supine. Erect is easier to do, right? But they can be supine on the table. You're going to start off by getting the patient in a SMV projection, which means you're going to hyperextend the neck to place the vertex of the skull on the image receptor. All right, and then what you're going to do from there is you're going to rotate the head 15 degrees towards the side of interest, and then tilt the chin 15 degrees towards the side of interest. So let's see if we're able to show you this, okay? So here's the SMV, right? All right, so what we're going to do is we're going to try to look at this zygomatic arch there. So hopefully it's, you can't see it because it's superimposed over the back of the skull here, right? So what we're going to do is we're going to rotate the head 15 degrees towards the area of interest, and then we're going to tilt 15 degrees towards the area of interest. Okay, so if you notice, right, again, let me move over this way, okay? Very difficult to see the zygomatic arch, right? So we're going to rotate 15 degrees, right? And I'm doing the, this is my right side, I'm doing the right side. So I'm going to rotate 15 degrees, and then notice, look, I'm going to tilt the chin again to my right side 15 degrees. And you see how that little space opens up right there. It brings this zygomatic arch away from the parietal bone. That's what we want to see. Okay, because I know it's hard to fathom that you're going to tilt the chin towards the side of interest because you feel like you're going to be going and getting in the way, right? But if we tilt the chin this way, it just gets more in the way. So again, for this superior oblique super inferior tangential projection, what we want to do is we want to rotate the head 15 degrees towards the side of interest, slight 15-degree rotation, and then tilt the chin 15 degrees towards the side of interest. So if I was rotating and I tilted the other way, no way you see that arch. All right, so again, pretty cool, right? You rotate and then you tilt and you'll see it open up. All right, I think that worked out pretty well. So if you look at this guy here, right, he rotated, oh my God, come on, go back. He rotated that way, and then his chin also tilted that way. Okay, so he rotated and tilted towards the side of interest. And we're gonna see this zygomatic arch, and you can kind of see the outline of it there, right, is what we wanna see. Okay. Once you've done that, your CR again is perpendicular to the IOML, because remember, we're still in an SMV position, so that IOML is still crucial and needs to be parallel to the image receptor. All right, so this CR should still be perpendicular to that IOML. Okay. Once you've done all that, you center to the zygomatic arch of interest, which means that you're going to center to this zygoma here, but what the CR it's going to do is it's going to kind of skim this mandible here, go through the arch, and then skim the parietal eminence of the parietal bone there, and then hit the image receptor. Okay, that's why it's called a tangential. It's just skimming the zygomatic arch. All right, collimate and suspend respiration. So again, get the patient in an SMV projection, right? And again, it's the right side here. We're going to rotate 15 degrees towards the side of interest and then tilt 15 degrees towards the side of interest. And your CR is going to come this way, right? It's going to come this way, skim this mandible here, skim the zygomatic arch, and then skim the parietal eminence of the parietal bone, right? And then it'll hit the image receptor. Hopefully that helped you to kind of visualize what it's going to do. Important thing to remember, it's 15 degrees head rotation towards the affected side, 15-degree tilt of the chin towards the affected side, okay? Here's what it looks like. This is what you want to see. You want to see that zygomatic arch in profile, right, demonstrated free of any superimposition, okay? If it's superimposed, that means you probably didn't tilt enough, okay? So if it's superimposed still over here, then that means that you probably didn't have enough 15-degree tilt on it, okay? Now, it could be either one, right? I mean, if we're doing this, let me show you, right? Because if it's too far, it's going to be superimposed over one structure, and not tilted enough, it's going to be superimposed over another. So let's stop this. Okay. So let's look at it, right? So again, we're going to do, let me try to get this straight here. 15-degree head rotation, 15-degree tilt, okay? So if I don't tilt enough, it stays superimposed over the parietal bone. If I tilt it just enough, I can see it, but if I tilt too much, now it's superimposed over the mandible, okay? So if you have it superimposed over the parietal bone, that means that you did not tilt enough. If it's superimposed over the mandible, you tilted too much. All right, and that is the oblique infrasuperior. So important thing to remember, started off as an SMV. All right, remember the criteria for an SMV. Vertex of the skull and the image receptor. IOML parallel to the image receptor, CR perpendicular to the IOML. Then from there, you're going to rotate the head 15 degrees towards the side of interest, tilt the chin 15 degrees towards the side of interest, and you're going to collimate, suspend respiration, center to the zygomatic arch of interest. Okay. If the zygomatic arch is superimposed over the parietal bone, you did not tilt enough. If it's superimposed over the mandible, you tilted too much. Right? Next one is the apiaxial modified town of zygomatic arch. We've done a town before, right? And this one here is on page 427. So it's very similar to a town projection, all right? Except now we're just looking at the zygomatic arches, okay? But the centering point did change. So 75 to 85 kVp, 40-inch SID, erect or supine, whichever one. You're going to depress the chin, right? Bring the head down to bring the IOML perpendicular. So look on here, right? We see that. Oh my God, go back. We see that IOML perpendicular. Okay. Now, if the IOML is perpendicular, we're going to center or angle our CR 37 degrees from the, 30 degrees from the OML. Okay. If the patient cannot depress the chin, then what are we going to do is we're going to use the IOML right there, right? So that means that IOML would now be where the OML is. But remember, there is a 7 to 8 degree difference between the IOML and OML. So what do we got to do to our CR? We got to adjust our CR and go 37 caudad to the IOML. These are caudad angles, right? So very similar to the town projection we did, right? We had the same positioning, the same angling. The only difference is the centering. For the town projection of the skull, we went 2.5 inches above the glabella. This one here is 1 inch superior to the nasion. So find the nasion, and you want to go 1 inch superior, right? And that's where you want to center. So it's not 2.5 inches above the glabella, it's 1 inch above the nasion. Collimate and suspend respiration. Now remember, it's important to remember when you collimate, you need to include the zygomatic arches, so make sure you get the entire skull. All right, here's what it looks like. Again, here are the zygomatic arches we're looking for. They should be seen in profile bilaterally. There should not be any superimposition, and they should look very symmetrical. Okay. All this right here, again, will be underexposed because we want the correct amount of exposure for the zygomatic arches. We don't want them to be overexposed. All right. So again, when you're positioning this patient, 30 degrees from the OML, 37 degrees from the IOML, just remember the centering point changed a little bit. It's 1 inch superior to the nasion. You want to see the zygomatic arches in profile, no rotation, and no motion. Okay. Last one, which we've done already, right, is the parieto-canthal waters projection of the zygomatic arches. So this one here, refer back to page 420 in your text. All right. We'll do again a 75 to 85 kVp, 40-inch SID. Erect is preferred, but you can do it prone. So remember for this one, we're going to extend the head, put the chin on the image receptor, right? And that will bring what positioning line perpendicular? The MML. All right. So again, extend the head, bring the chin on the image receptor, and I'll do a side view here. All right. So for the patients like this, facing the image receptor, you're going to extend the chin, bring the MML perpendicular to the image receptor, okay? That forms a 37-degree angle between the CR, between the OML and the IR, right? Not the CR. So why is that important to have that 37-degree angle? And I'm going to ask you a lot, so just get used to it. It's important to have that 37-degree angle between the OML and the table or the IR is because it helps to guarantee that the ridges will be below the maxillary sinuses, okay? So again, 37-degree between the OML and the IR guarantees that the ridges will be below the maxillary sinuses. Make sure there's no rotation or tilt of the patient. And we're going to center to exit at the acanthion again, right? The parieto-canthal projection. Collimate, suspend respiration. Okay. Here's what it looks like. Now the structures we're looking for, right? Because we also use this for the nasal bone, which was right here. We're looking for these structures there. All right. Everybody see that? That goes this right here, right there. That is your zygomatic arches on each side. That's what we want to see. So that's why it's important to be careful with your collimation, right? Because they almost chopped off those zygomatic arches that we're looking for. All right. But if you notice, right, this waters projection shows you the orbits, the nasal bone, the sinuses, the zygomatic arches. So it's going to be used for a lot of different exams, right? So when we do orbits, we're going to use this. When we do sinuses, we're going to use this. We did it for nasal bones, and now we're doing it for zygomatic arches. Okay, so again, that's what we want to see, those zygomatic arches. Make sure they're located on there and they're not cut off by your collimation, right? But getting back to the waters projection, how do we know if it's a good waters projection? All right, what are we looking for on the radiograph? Hopefully you said the Petrus ridges should be well below the maxillary sinuses. If you said that, then you are correct. Yes, we want them below the maxillary sinuses. That helps us to know that we had a good waters projection. What happens if you see the ridges in the maxillary sinuses? Then that means you didn't extend the head enough, right? The head was too far low. You need to extend them to bring those ridges underneath the maxillary sinuses, right? Remember I told you all to put the, let me erase this first. Remember I told you all to put the hands, right? You put your fingers here, right? Those are your ridges in the orbits. What happens is I raise my chin. They go low, right? I keep going, right? And they're going to go below the maxillary sinuses, which are right here. So they're down here. But if I don't go extend enough, they're right in my maxillary sinuses. So I want to make sure my neck is extended to bring that chin on the image receptor. That way those ridges are well below the maxillary sinuses. All right, and then of course, no rotation. We check. Oh, don't go back there. Why do you do that? From there to there, from there to there, right? Those distances there, make sure there's no rotation. Also no motion, optimal exposure factors, okay? Here's a review we went over last time with all the stuff. All right, so let's look at some radiographs of these two. Again, if it went a little too fast or you need to go back, that's what this video is for. You can rewind, fast forward, you can take notes, stop it, pause it. So this is for you, right? So make sure you take advantage of this because, you know, normally in class, we just kind of be going through lecture. You wouldn't be able to, you know, you'd ask questions, but you may forget what to ask or not, you know, think of something later. You can always go back to this video, watch it, just pause it, you know, whatever you need to do, okay? So here's some projections of the nasal bone. The fractures, and they're going to show you different fractures, right? So if we see here, the arrow points to one fracture there. Okay, so little line across the nasal bone. But this is what you want to see, that nasal bone there. This stuff's going to be kind of underexposed. You can see a little bit of it because it's digital, but it looks real grainy because it's underexposed. Okay, but again, this is a fracture of the lateral. Another lateral projection shows another fracture, very obvious, right? We can see it all right there, okay? So again, you see how they didn't take a lot. They don't, their collimation isn't wide open, right? They're collimated just to the area of interest, which is what we want to see. Okay. So we look here, this is a Caldwell projection, right? Which is the bad one? Okay, so is it 1 or 2? Which one is the bad one? All right, if you said 1, you are correct. 1 is the bad one, okay? Because this is a Caldwell projection, so where should the ridges be? In the lower 1/3, right? If you look here, they're in the lower 1/3, but here, they're below the orbits, okay? So what was the error over here? Right, error was that they weren't flexed enough or that they had too much angle of the CR, okay? Either not flexed enough or too much angle of the CR, right? But again, for these nasal bones, this is what we want to see. We want to see that bony nasal septum there, right, on each one. And we can see it. All right, here's a zygomatic arch, SMB. So this right here, look at that. Monster fracture, right? Now, if you notice that depression fracture is kind of getting superimposed by the parietal bone back there. So that's why we do that oblique supero-inferior projection to kind of bring that zygomatic arch away, okay? It's another example of the SMV depression fracture, right? So again, it's pushed in towards the parietal bone. So which projection should we do to kind of help see that? It would be that oblique projection for sure. Okay? I'm just kind of trying to show you all some different fractures of the SMV. All right, so for this one here, where do you think the fracture is of the zygomatic arches? There is one, and which one do you think it is? You think it's on the right side or left side? Look at it very carefully. It's Waters projection. So if you said that the the fracture of the arch is on the right side, you are wrong, right? It's on the left side, right there. You see how it kind of comes this way and then kind of sharply goes down? You want it to be round like this one here. Okay, so I'm gonna take this off so you can see it, but yeah, the fracture is definitely right there on the left side. Okay. All right, so let's look at these two radiographs. Which radiograph demonstrates one or more repeatable errors, A or B? And this is supposed to be a Waters. Give you a little bit of time. All right, in 3, 2, 1. What did you say? It is A, right? So A is the bad one. So A right there, that's the bad one. Okay, now, don't worry, we're going to go over another question. What are the errors in radiograph A? All right, I'll give you a few seconds to look at it. Remember, it's a Waters projection. All right, you ready? Okay, so for Waters projection, what are we supposed to see as far as the ridges? Where should they be on a Waters projection? They should be well below the maxillary sinuses, right? And where are these? Right in the maxillary sinuses. So what does that tell you when you have those ridges in the maxillary sinuses? That means that they were not extended enough, or it was excessive flexion, right? So insufficient extension, or it was excessive flexion, okay? So again, if you see those ridges in the maxillary sinuses, that means their head was too low, okay? What else? No marker, right? Definitely. And then also, if we're looking at the zygomatic arches here, what happened? They were cut off, right? So you have a collimation problem. So remember, when you're doing these Waters projections, right, you're most of the time you want to make sure you include the entire skull. That way you can see all of the facial bones, okay? So insufficient extension, no marker, and then collimation problem. All right. What is the angle between the OML and the plane of the IR for a well-positioned parieto-canthal projection? I went over this like a few times already, right? So which one do you think it is? It should be 37 degrees. Right now, that's important because that'll make sure that the ridges are below maxillary sinuses. Okay, as that angle goes up, the ridges go up as well. Right, so as the angle as that angle increases, right, those ridges start going up. Okay, so be careful that you stay at that 37-degree angle. All right, let me erase all that. You said 37 degrees, you were correct. What is the positioning error for a parieto-canthal projection if the petrous ridges are within the maxillary sinuses? Oh, it's easy money, right? Easy money. So again, they're supposed to be well below, right? But if they're in the maxillary sinuses, then what happened? Did I have excessive flexion, excessive extension, rotation of the skull, or tilt of the skull? Well, they're supposed to be down here, but now they're here. I have excessive flexion, right? Excessive extension would have been this way, so it's excessive flexion. Rotation of the skull doesn't have anything to do with it. Tilt of the skull either. Okay, so the answer should have been excessive flexion. All right. And that's it, guys. That was the PowerPoint. If you have any questions over anything, again, you can email me, or when we're in lab, you can ask me while we're in there. But that's it. So make sure you go over the nasal bone and the zygomatic arches. Really, there's not a lot of extra projections we did, maybe 2 or 3. A lot of them you're going to refer back to the facial bone series. But the Waters is a big one that we learned, right? So make sure you know, really understand that one because that one's going to be used a lot. And then make sure you go over that oblique for the zygomatic arches. Again, guys, if you have any questions, let me know, email me. But hopefully this helped you to kind of understand our positioning. And we will be in the lab next week, and you'll be positioning some of these in the lab. Okay. All right, guys. Well, have a good evening. We'll see you all in lab.